Every night, we look at this pale, silent sphere shining in the icy void of space. It seems to us that the moon is dead, motionless, and forever frozen in its serene sleep. But right now, while you are watching this video, deep beneath its gray, dusty shell, something terrifying is awakening. Our faithful cosmic satellite, which has warmed the Earth with its soft light for centuries, has begun to slowly crumble and shrink from the unbearable internal cold.
Imagine that you left a ripe, juicy apple on the table, and over time it dried up, turning into a shriveled little lump covered in deep wrinkles. Roughly the same thing is happening right now to the huge celestial body hovering right above our heads. The moon is literally shriveling like an old raisin, and its hard, rocky skin cannot withstand such furious pressure. It is bursting at the seams, breaking and crumpling into giant folds, generating powerful and destructive underground tremors. And this is not fiction, not a plot for a new Hollywood apocalypse movie, but a harsh and frightening reality confirmed by the most modern space probes.
How did scientists even find out about this cosmic drama? It all started quite a long time ago, during the legendary Apollo missions. When brave astronauts jumped on the lunar surface like grasshoppers in clumsy spacesuits, they didn't just collect rocks and plant pretty flags. They left very sensitive and important instruments on the surface of our satellite, called seismographs. These are special devices that can listen to the pulse of the planet, catching the slightest vibrations of the soil. Imagine a super-sensitive ear pressed to the ground. The astronauts flew home, and these instruments remained working in the icy silence for many years. They listened to the moon until the late 70s of the last century, and what they recorded initially made scientists scratch their heads in surprise. Our satellite, which everyone considered an absolutely dead piece of rock, constantly shuddered from powerful tremors. These tremors are called moonquakes, and they differ greatly from our earthly earthquakes. On Earth, everything happens because huge plates of land and ocean floor are constantly moving, colliding and rubbing against each other like bumper cars in an amusement park. There are no plates on the moon. It is solid, like a billiard ball. Where then do these terrible blows from the depths come from? New lunar probes, which are flying around the satellite right now and taking incredibly clear photographs, helped solve this riddle. When astronomers compared old maps and new high-resolution images, they gasped with delight and slight fright. The surface of the moon turned out to be covered with fresh, huge scars. These scars look like giant cliffs and ledges, the height of a multi-story building and tens of kilometers long. They look like huge steps that have grown right in the middle of flat lunar seas and craters. The most interesting thing is that these cliffs literally cut into relatively young, small craters, which means they appeared quite recently by cosmic standards. The moon is changing right before our eyes. Why is it shrinking? It's all about temperature. The moon was born billions of years ago, and back then it was a real hellish sphere covered with oceans of bubbling molten lava. Over time, the outer part cooled down and turned into a solid stone crust. But deep inside, in the very heart of the moon, a hot metal core still remained. And right now, this core is rapidly losing the last remnants of its ancient heat. When any substance cools, it shrinks in size. You can notice this in winter when, due to the cold, the iron swings in the yard become slightly smaller, and in summer, in the heat, they expand again. The lunar core is cooling and shrinking, and with it, the inner layers of the satellite are shrinking too. But here's the catch. The outer rocky crust of the moon has long since become hard, brittle, and cold. It cannot simply shrink in size like soft Play-Doh. It simply lacks space on the shriveling inner sphere. And then the inevitable happens.
the strong stone armor begins to break under its own weight. One huge piece of lunar crust overrides another, squeezing huge rocks upward. Physicists call this process thrust faults. At the moment when the rock cannot withstand it and breaks with a crack, a powerful moonquake is born. If you were standing on the moon at this moment, you would feel the whole world around you begin to shake wildly. And this is completely unlike earthly tremors. On Earth, an earthquake usually lasts a couple of minutes at most, because inside our planet there is a lot of liquid water and soft molten mantle that dampen vibrations like a huge pillow. The moon, on the other hand, is dry, solid, and frozen solid through and through. It is like a huge crystal glass. If you strike a crystal glass, it will ring for a very long time. So will the moon. When a rock breaks in its bowels, the entire planet begins to vibrate and hum like a bell. Moonquakes can last for a whole hour, and sometimes for several hours in a row. Imagine a whole hour of continuous, furious shaking from which huge boulders fly off in all directions. It is a truly frightening sight.
Over the past few 100 million years, the moon has lost about 45 meters in girth. It seems that this is quite a bit for such a huge celestial body because its diameter is 3,500 kilometers. It is as if a huge, plump elephant lost one tiny millimeter. But for the fragile lunar crust, even such a tiny contraction turned into a real disaster. The entire surface was covered with thousands of sharp faults. And this problem has become a headache for all space agencies, especially for NASA. After all, right now, people are preparing with all their might to return to the moon. The new Artemis space program plans not just to send people there for a couple of days so they can take a walk and fly back. Scientists want to build a real permanent base there, a home for astronauts, scientific laboratories, and even factories. And the best place for such a base, scientists thought, is the south pole of the moon. There, in deep craters where the sun never peaks, hide huge reserves of cosmic ice. From this ice, you can extract water for drinking and oxygen for breathing, as well as make fuel for rockets to fly further to the distant and mysterious Mars. This is an ideal starting point for humanity into deep space. But here is the irony. It was precisely at the south pole of the moon that scientists discovered the freshest, most enormous faults and traces of recent powerful moonquakes. One of the strongest tremors ever recorded by Apollo instruments occurred right in the area where NASA had set its sights on landing sites for its new ships. This changes absolutely all plans. Building a lunar base next to such a fault is like building a beautiful glass house on the slope of an active volcano or on the line of the most dangerous earthly San Andreas Fault in California.
If astronauts start building their houses from light materials, the very first powerful hour-long lunar quake could turn an expensive base into a pile of space junk. The cracks could tear apart the pressurized modules, precious air would escape into the airless vacuum, and the buildings themselves would simply collapse into the formed abysses. Furthermore, due to the weak gravity on the moon, moonquakes cause terrifying landslides. The steep slopes of the craters, covered with fine, slippery dust, can collapse downwards in a single moment, burying scientific instruments and lunar rovers underneath. So engineers will now have to invent completely new technologies, building structures on special springs or cushions that can withstand the cosmic rocking. Our satellite clearly lets us know that it is not going to surrender without a fight and does not await guests with open arms.
But here, every reasonable inhabitant of Earth will necessarily have a reasonable and very important question. If our faithful satellite is suffering so much, shrinking, breaking, and decreasing in size, how will this affect you and me? After all, the Earth and the Moon are connected by invisible but incredibly strong bonds of gravity.
They are like an inseparable dancing couple in a cosmic waltz, where every step of one partner affects the other.
Let's figure out if we should panic and build underground bunkers. The first thing everyone immediately remembers is, of course, the ocean tides. It is the moon that, with its gravity, like a huge invisible magnet, pulls the water of the Earth's oceans towards itself, causing it to rise and fall twice a day. If the moon becomes a little smaller, will its gravitational pull change? Scientists are quick to reassure us. Fortunately for all beach lovers and sea captains, the total mass of the moon remains absolutely the same. From the fact that it is cooling and shrinking, rocks and metals do not fly out of it into open space. It simply becomes denser and more compact. It's as if you took a large, fluffy piece of cotton wool and squeezed it tightly in your fist, turning it into a small, dense ball. The weight of the cotton wool has not changed, only its size has changed. And since the mass of the moon does not change, its gravitational force remains the same. The Earth's oceans will breathe exactly the same way as they did millions of years ago. The tides will not turn into giant destructive tsunamis, and we can sleep peacefully.
Lunar shrinking will also not affect the tectonics of the Earth's plates in any way. That is, our earthquakes and volcanoes. Our planet is much larger, heavier, and hotter than its small satellite. The Earth itself perfectly manages to arrange upheavals for us without any outside help. So in this regard, the moon is absolutely safe for us. It is destroying only itself, quietly and alone in the cosmic silence.
However, there is one more curious detail that makes scientists think. The moon is not just shrinking, it is also slowly but surely moving away from the Earth. Every year, it flies away from us by about 3.8 centimeters. This happens due to a complex gravitational interaction and the friction of tidal waves against the ocean floor. A very interesting cosmic picture emerges. Our satellite is simultaneously shrinking in size and running further and further away into the dark abyss. In billions of years, it will look like a tiny, barely noticeable star in our sky. But that moment is still very, very far away, so we will have time to enjoy beautiful full moons.
The study of moonquakes and the shrinking of the moon opens up amazing scientific horizons for humanity. It shows how little we still know about those worlds that are very close to us. We have learned to look into distant galaxies, millions of light years away, but our own cosmic neighbor still hides incredible secrets right beneath its surface. Every new crack on the moon, every shudder it makes, is an invaluable lesson for earthly scientists. It is an opportunity to understand how planets die and cool down, how their interiors are structured, and what awaits the Earth itself in the very distant future. Space once again proves to us that it is alive, dynamic, and full of amazing surprises.
Our virtual journey to the bursting satellite has come to an end. The universe is an incredible, grandiose mechanism where even the cooling of a small lunar core can change humanity's plans for space exploration. It reminds us of what tiny, but at the same time brave creatures we are, trying to unravel the secrets of the starry sky. A huge thank you to each of you for watching this video to the very end. You are the best and most curious viewers. If you found it interesting and want to travel more often with us to the most hidden corners of space, be sure to give this video a like. Write in the comments what you think about moonquakes, and would you like to live on a lunar base, knowing that the rock under your feet could crack at any moment? Do not forget to subscribe to the channel and click on the bell so as not to miss our new exciting stories. Stay with us and see you next time.